Okay, in this video, we will see how to plot 2D drawings from a 3D model assembly. So we have protected flange coupling and we were told to plot assembly of assembly drawing, and we need to plot front view, upper half in section and side view of the assembly. Okay, apart from that, we have to also give the bill of material. So first we will make the layout ready. So if you see the layout, okay, we will clear this layout here, and we will reset the page settings here. So I will select this and delete it. Next I will go to right click, page setup manager. In page setup manager I have layout 1. I'll go to modify. Okay, I'll set the plotter to DWG to PDF. I'll change the paper size to A3 in landscape mode. I'll check plot transparency and press OK. Okay, close this and my page is ready in the A3 format. Okay, now I need to first bring the template here. I already have the template ready. So I will select this template, press Ctrl C, don't press copy, press Ctrl C, come here and press Ctrl V. Okay, and then we can align this properly. Okay, once it is aligned, I will save this, go back to my model space. Okay, now I will utilize the settings. You can go to this base view, check this arrow and check whether it is in first angle. Okay, next select the base, from model space select the entire assembly, press enter, select the layout 1, press enter again. Okay, now I am getting this front view, but I need left hand side view first because my front view is in section. Okay, so I will select left first. Okay, my scale is proper. I'll select left hand side view. Okay, press enter once, press enter twice. Okay, I have the front side view ready. Now I will select this, go to section, select the half because we have the upper half in section. Now in order to select the half section, we need to select a quadrant. So I will take this point a little bit extended outside the body, select the second point as the center and third point on this side outside the body. I have the front view ready with me. I will just select the position and press enter. Okay, so now here in this form my nut and bolt are in the opposite direction. Okay, so you can change that also and you will get to see. Go to layout 1 and you can see this is already changed. Okay, you can still say update view, you can still say update view. Okay, now come to this and select or hover over this particular point. You can say add vertex. After adding vertex you can always go to select this. Okay, make sure it is in one line only, straight line. Okay, so the arrow should be pointing downwards here in this way and here it should point in front. So this is your upper half section line. Now here I will remove this text. I don't want this. I will make one more text for that. Okay, separate text. I will turn this transparency hatching of this bolt, and I will turn this transparency to 90. Okay, same for the nut. I'll turn the transparency to 90. Close. Okay, this indicates that there is a nut and bolt here. Okay, now after this I will take the center line. So I will take any one line here, and I will create a line. I'll turn this line into a center line. Okay, if this center line layer is not there, you can always go back to your layers. Okay, and you can create a layer here. Layer properties, you can create a layer of center line. Select the center line. Okay, after selecting or creating that layer, come here and select this line as a center line. Double click. If the line type scaling is very less, just increase the line type scaling properly so that it is visible to the full sheet also. Now once this is done, I will make the centers. So I will copy. Okay, extend this. Okay, so I have the center line. Same, I will utilize this. I'll copy. Okay, I'll copy from reference here, center to center, and you will see this will be exactly aligned. Okay, next I will also take this copy and I will align it here. From here I'll take this and align it from here. Okay, okay, I won't overlap this line. Now I will take circle from the center and align this here. Okay, I can change the properties using the match properties window. I will change this center circle to the PCD circle. Now this is my PCD circle. Okay, I can always go to annotate and use the center mark to make this center. Okay, so the center is aligned. I can also use the match properties and give it to the center mark. Okay, give it to the center mark. Now here I will make dimensions. So clear dimensions can be given. First I will make the dimensions which are on the outside. The largest dimension goes outside. Sorry, this should be from here, 80. Again, align it properly using chain dimension standards. Next is 40. Okay, we can always reassociate that later on, because in print it will not show. This error will not show in print. Align this 22 also. Save your work. Next, we can also give the total dimension. Always, you can also give the total assembly dimension. This will be realigned. Okay, and you can give the dimensions for the width also. Yeah, you can also give the dimensions for the PCD. Okay, so this is where the this is PCD. I will say %C, which is a shortcut, or you can also go to symbols and select the diameter here. So 158, and you can close this. Okay, or basically this is PCD, so I will write diameter PCD. Sorry, I'll just write PCD, that is pitch circle diameter 158. Okay, in this way you can give all the dimensions. I will make sure that the dimensions which are given in the diameter, they are either aligned to 30° or 45° in the quadrants properly. So I will mark first, this is my 214. Okay, I need this is aligned, but I have to change the dimension settings to ISO standard. So modify, go to text, ISO standard. Okay, also make sure in primary units the zero compression is trailing is checked on. Okay, if you feel that the dimensions are very small, you can always change the text size of the dimension. Okay, this is aligned, and you can align one more. Okay, here in the same direction, dia 120, that is the hub dia 60, it is the shaft dia. You can change it on the other side. So you can see here on this side I have given 45° angle because only one diameter. Here two diameters in same quadrant, so one on 30, the other on 60°. This is the proper dimensioning standards for giving the diameters. Next I will give the thickness. 5 mm thickness. Okay, what else is remaining? You can see, okay, 40, 22, 80, 92 and 5 is remaining. So I will, and this 10 also. So I'll go back and I will give this, okay, 5 mm. Okay, or you can take this outside also, but make sure it is not overlapping any line. Okay, you can give 10 mm here and take this text outside or on this side, because here we have the key also. Okay, next we will have yes, dia 92 was remaining. So again, read diameter, this dia 92. Okay, we can also give the thickness of the width and the thickness of the key. Okay, so I think almost all the dimensions are covered up. If any dimensions are remaining, you can just see that. This we can make this multi-leader holes here, and we will directly see that if there are 4 numbers, so it is not required that dia 18 holes. Okay. Yeah. Now we will actually go to the in my next videos, you will be able to see how I give the multi-leaders and the bill of material, which will complete this entire drawing. Okay, thank you.